Okay, so I'm going to run this command p9qemu image create. I'm on Windows right now. Um, I'm providing a URL to what I want to install, and then I'm giving the instance a name. I'll just call it dev-a. So where I got that URL from is on my p9qemu project on GitHub. If I go to releases, there's a few different releases here. So I just went to the latest one, and there you can see the full command that I'm running to create an instance, which is right there. So I just copied that and pasted it into the terminal. So this is basically Ninefront as of this release, which is the last major release, not the one that just came out. It's for AMD 64. It's going to use the HJFS file system, time zone set to GMT, and draw term is enabled out of the box. Okay, so I've got my command loaded here in the terminal. I'm going to hit enter, and it's going to go ahead and do its thing. Now, the first time that I run this with this instance, it's going to download the ISO images from the GitHub package. So basically, if you go to the release here under assets, you'll see there's a tar GZ. It's about 239 megabytes. So if I've never installed this instance before, then it'll download that and put it in a cache location. But since I've already run this before, it's going to use the locally saved image files to actually do the instance or to set up the instance. And in this case, we can see it's completed. So I'm in this directory here under my home directory, VM, and then let's say I have a project called ABC. That's where I want to have Plan 9 VMs for this project. So if I just look in here, I can see we have our instance there, dev-a. If I look in that directory, we can see a really small image file, disk.qcal2. And it's a very small image file because it's an overlay off of the main image, which is immutable. Now, as we use this Plan 9 instance, this will grow. This image will grow as we start to use the disk. Okay, let's say now I want to start up that instance. I'll run p9qemu start. I'll specify the instance we want to use, which is that dev-a. And importantly, I'm going to specify the address to use. So I'm going to do a loopback address 127.0.0.100. And I'm on Windows, so I can use this XL WHPX. Okay, so let's start up this instance. I'm going to hit enter there and give it a few moments. Okay, so the QEMU console comes up. It's booting. I'm going to move that over there. And okay, I'll let it finish booting. Okay, Plan 9 has finished booting here. Now, when I start this instance, it shows you information about the image that it's using. And importantly, it also shows you the QEMU command that was used to start the instance. So that's right here. I didn't have to run that manually. p9qemu is taking care of that. But if I want to see like what settings it's using for that instance, they're all shown right here. In my case, I have a lot of ports being forwarded. I probably don't need that many, but anyway, that's just what I have for now. Okay, now I've opened up another terminal because I want to connect to this Plan 9 instance using drawTerm. And here's the command I'm going to use. I've got this default password set up in an environment variable and the IP address and then my drawTerm command, and I'm just going to run Rio. So, and I'll use that to run it in the background. So I'll hit enter there. We get our drawTerm window. Give it a couple of seconds to connect. All right, and we're in. And yep, okay, everything's working as expected. Okay, so now in another tab, I'm going to run a similar p9qemu image create command with the same remote image, but I'm going to specify a different instance. Now I'm going to do dev-b just to have a separate VM for testing. So I'll go ahead and run that. It's going to do the same thing as it did before. It's going to use the locally stored cache for the image, and I'll let that finish setting up. Okay, once it's done, we can see there we have another folder for the second instance, dev-b. Okay, and now I'm going to start the instance. I'm going to specify the dev-b instance, And I'm going to use a different loopback address. So now 101. The first one was dot 100. Now this one's dot 101. So I'm going to run that. And now we'll get another QEMU console window. Again, it shows us the command that it used. I'm going to move the console down here while it boots. And so we can see here the settings that it used. Obviously, different IP address for all the port forwarding. So that's all taken care of for us since we specified it on the command line there. All right, I'm going to let that finish booting. All right, so our second instance is running. Now I'm going to come back to this other terminal and start draw term again, except now I'm going to specify the other IP address. I'm also going to run Rio, and I'll submit that. Okay, we get another draw term. Let that finish logging in. Okay, cool. All right, so there we have our two QEMU instances. Each of them I've draw termed into, or I've draw termed into each of them there. So why am I using, why did I decide to explore something like this, like p9qemu? Well, what I had been doing before was like a very manual process. If I wanted to install, Plan 9, I would download the ISO. I would have, like, sometimes I'm on Linux, sometimes I'm on Windows. If I'm on Linux, I would have, kind of these quickly thrown together ad hoc bash scripts that would, have all the settings I was going to use for QEMU. And I would have the ISO here. I would have the resulting image that I was going to use for the disk, and then I would run the script. And that worked, and that was good for like understanding what's going on behind the scenes. But I just ended up with like all these different directories with different images, and kind of organizing them all was just very sort of on the fly, very touch and go. Now here's another terminal window where I'm on Windows. This was in Linux WSL, and here on Windows, similar setup. I would have an image file, and I would have now PowerShell scripts that would set up QEMU. So basically, I would have very similar scripts that kind of depended on where I was running them. If I was on Windows, I'd have PowerShell scripts. If I was on Linux, I would have Bash scripts, and so forth. So p9qemu is basically a front end to all of that, and I went with Python. That way, it's just one code base that works on both Windows and Linux. On my bash scripts, I'd also been messing around with scripts that would take care of downloading the official 9-front ISO automatically for me, like if I ever wanted to install from scratch. And that was cool, but then, I ended up with just ISOs kind of littered all over the place. So that's something else that I wanted p9qemu to take care of, is just to download, an image once and store it somewhere, and it's immutable, so I'm not going to be changing it. I can just use that for all future installs. And also, as I showed you here, I wanted the ability to easily change IP addresses, and I could do that by parameterizing the bash script or the PowerShell script. But again, I didn't want to have to do that in multiple places, so I just figured, okay, one uniform way to, manage and start P9, sorry, to start QEMU. If I had such a like central utility, I could then have things like, all right, an easy way to specify what IP address to assign it as far as like the loopback address. So p9qemu was basically just a way to consolidate some of the workflow patterns that I've developed over time relating to like shell scripts and QEMU and Plan 9. So far I've tested this on Windows and Linux. I have not tested it on Mac yet. p9qemu, as I mentioned, is a Python script, and it's a package that's set up with UV. So, and of course it uses QEMU on whatever OS you're on. So you want to make sure QEMU is installed. And then as far as installing p9qemu, it's you can use UV to do that. So it's basically just this one-liner UV tool install, and then the Git repository for p9qemu, and that's it. You've got p9qemu installed. So this is just a tool that I wanted to use to simplify my personal workflow. I wouldn't necessarily say this is ready for everybody else to use. I'm just sharing this to show kind of how I use Plan 9 VMs and quickly, spin them up. And most importantly, I wanted this workflow where I could just say, create a new instance. It's, very fast to set up. And after I boot it, it's ready to draw term in. So there's no weird setup. I'm having to go through these additional steps to get it ready to, to log in remotely. Oh, and as I mentioned, since the binary releases are stored on GitHub, whenever I do one of these installs and it does happen to download an image, like I said, usually when I run this, it's just grabbing from the locally cached image. But whenever it does download, it's downloading from GitHub, so I'm not hammering the 9front servers. So like I said, this is not something that's necessarily ready for everybody else to use. I just wanted to share kind of how I've sort of simplified and consolidated my workflow. So if you look in my VM directory, I have a bunch of project directories there. So I was messing around with installing this program called legmax. So I just made a directory just for that, and I have some VMs in there that were just devoted to experimenting with that program. So in that legmax directory, you can see. By the way, legmax is a kind of like an Emacs like editor written in Clojure dialect, and this Clojure dialect, it's written in Go, and so Go runs on Plan 9. So basically, this legmax editor runs on Plan 9. Has some issues, but I've been like testing it lately. But anyway, in that project directory with the VMs, I've got a baseline image, which, as you can see here, it's pretty small. It's just like 9front, just set up to draw term in with a few customizations. And then what I did was I shut that down and then I copied it and then I installed Go into this other instance. That's like my Go checkpoint. That's a different VM, and it's basically just a snapshot with Go installed. And you can see there, it thrashed the disk enough so that the overlay image grew quite a bit there. And so then when I wanted to work with that image, I don't, basically I treat these checkpoints as immutable. So once I have Go installed, I shut that down and then I just I just copy that directory over to dev, and now dev is my working directory. So if anything ever gets messed up in the dev setup, I can always go back to like the baseline image with Go installed here. This is all basic, QEMU workflow stuff using images, but like I said, everything's just a little more organized, and I'm using overlays so the different images are smaller than, or I guess they're as small as they need to be. Anyway, that's all I wanted to share for now. There are some other things that p9qemu does. For example, it can automate a 9front install, like it will use things like pexpect to automate all the answers given an answer file, so it can walk through and install in an automated fashion. I don't do that very often. I usually just use these pre-made images, but it is capable of that because I also wanted a way to go through and install using answers, kind of specific answers to the different prompts. I'm not going to demo that here because that's a little bit more of an unusual process, but it's something that I also wanted to do in order to have reproducible installs. Okay, thanks for watching. And one final reminder, I really, really am not sharing this with the intention of saying, hey, this is ready for everybody to use. I'm just sharing my workflow. It is available on GitHub if you want to mess around with it. But yeah, no guarantees that it'll work for you.